JK Mathematics classes. Today I will discuss class 10 Maths chapter 2 Polynomials exercise 2.1 graph of a polynomial and part 2. So relationship between zeros and coefficients. So first zeros of quadratic polynomial, zeros of quadratic polynomial. If alpha and beta are the zeros of quadratic polynomial, P of x equals to, so standard form of quadratic polynomial ax square plus bx plus c, where a not equal to 0. If alpha and beta are the zeros of quadratic polynomial P of x, ax square plus bx plus c, a not equal to 0, then so sum of zeros, that means sum of zeros means alpha plus beta equals to minus b by a. So b is the coefficient of x, so we write minus, again b place coefficient of x divided by coefficient of x square, again product of zeros. Product of zeros means alpha into beta, so equals to c by a. C means constant term, no variable included, so constant term divided by coefficient of x square, constant term divided by coefficient of x square. Again quadratic polynomial. Forming a polynomial, quadratic polynomial P of x with zeros with alpha and beta are the zeros, can be expressed as P of x equals to k into x square minus alpha plus beta into x plus alpha beta, where k is a constant, where k is a constant. K is a constant. So suppose quadratic polynomial P of x with alpha and beta are the zeros can be expressed as P of x equal to K into bracket x square minus in bracket alpha plus beta into x plus alpha beta. So where K is a constant. Again it also be written as K into x minus alpha into x minus beta. Since alpha and beta are the zeros of P of x, then x minus alpha and x minus beta are the factors of P of x. And next, graph of a polynomial. So graph of a polynomial. Graph means geometrical representation. Polynomial. So geometrical representation of linear polynomial. Geometrical representation representation of a linear polynomial geometrical representation of a linear polynomial. So linear polynomial is of the form ax plus b. So each graphical representation is a straight line. So graph of a linear polynomial. So graph of a linear polynomial. Graph of a linear polynomial P of x equals to ax plus b, where a not equal to 0 is a straight line. Intersect x-axis. Intersect x-axis at one exactly at one point. That means linear polynomial. Graph of a linear polynomial, suppose ax plus b is a straight line, intersect the x-axis exactly at one point. So linear polynomial have only one zeros. Suppose a graph of any polynomial intersect the x-axis. So graph of a linear polynomial intersect the x-axis exactly at one point. So its zeros will be 1. This is a graph. So x left 2 zeros. So x dash again above y, below y dash. So here this is a graph. This graph intersect x-axis only one point. So it zeros 1. Again, geometrical representation of a geometrical representation of a quadratic polynomial. So geometrical representation of a quadratic polynomial. So graph of a quadratic polynomial is a parabola. Graph of a quadratic polynomial p of x equal to ax square plus, so standard form of quadratic polynomial is ax square plus bx plus c, where a not equal to 0 is a parabola. Graph of a quadratic polynomial p of x equal to ax square plus bx plus c is a parabola, open upward, upwards if a greater than 0. That means coefficient of x square greater than 0. For example, 5x square plus 4x plus 1. So graph of a quadratic polynomial is a parabola open upward if a greater than 0. So catch x-axis at 2 points. So graph of a quadratic polynomial zero. So open upward means this parabola intersect x-axis at 2 points. So this point and this point. Suppose this is A and B. So x, y, x dash and y dash. Okay, next, graph of a quadratic polynomial p of x is equal ax square plus bx plus c, where a not equal to 0. A not equal to 0 is a parabola open. Suppose if a greater than 0, open upwards or open. Suppose a less than 0, then open downwards. If a less than 0. For example, minus x square plus 7x or 5x, suppose 5x plus 1. Again graph. So x dash, y dash. So open downwards means this graph cuts x-axis at 2 points. In general, a polynomial p of x, suppose note, polynomial polynomial p of x of degree n, p of x of degree n, intersect the x-axis, at most, intersect the x-axis at most n points. That means number of zeros is equal to degree. Suppose n degree polynomial have n zeros and quadratic have 2 zeros. Again start exercise 2.1. Exercise 2.1. So the graph of y equal to p of x. Suppose question number 1. The graph of y equal to p of x are given in figure below. Given in figure below, for some polynomial polynomials p of x, find the number of zeros. Find the number of zeros of p of x in each case. So first graph. Graph of this polynomial does not catch x-axis. That means does not intersect the x-axis. So number of zeros is 0. So number of zeros is nil. That means number of zeros equal to 0. Again next graph. So next graph. X dash, y dash. Again this graph intersect x-axis at one point, so number of zeros is 1. So it has 1 zeros, so number of zeros 1. That means this graph intersect x-axis at one point only. The next third number. 0 x dash y dash. So this graph intersect x-axis at 2 points, this point and this point, only x-axis, not y. We measure only catch the x-axis, not y-axis. So number of zeros is equal 2. Suppose a graph cuts x-axis at 2 points, the number of zeros 2. Again, next 4 number. X dash, y dash. And this graph cuts x-axis at 2 points also. So number of zeros 2, also 2. Number of zeros also 2. This graph intersect x-axis at 3 points. So number of zeros 3, 1, 2 and 3. 1, 2 and 3. Next, this graph cuts x-axis at 2 points. So number of zeros 2. Again 5 number. Next 5 number. So x dash, y dash, again 0. This graph cuts x-axis at 4 points, 1, 2, 3 and 4. So number of zeros 4. Number of zeros is equal 4. So this graph cuts x-axis at 4 points, so 1, 2, 3 and 4. So number of zeros 4 points. 4 points, so number of zeros 4. Again 6 number. X dash, y dash. This graph cuts x-axis at 3 points. This point, this and this. 3 points. So number of zeros 3. So number of zeros 3. So today class is finished.